In this graph, here the strobe is flashing at a certain rate, and we see the position at the ball at successive instants of time. Now we've increased the rate at which the strobe is flashing, and we see the same picture again, but the measurements have been refined, so we have more time points. And the same thing is shown again, repeated. It has been refined to show even more time points and to show where the ball was at each of these successive instants. Here what we've done is we've graphed this data on a y versus t axis, and we see the same set of three graphs. Again, one of them has only few time points, another one has more, and the third one has yet more time points. This is the first image, the same thing with more time points, and again the same thing with yet more time points. Finally, what we're going to do with this graph is compute the average velocity between 2 points, let's say this point and the second point, which basically is simply the slope of the line joining those 2 points. From that average velocity, we'll then arrive at the concept of an instantaneous velocity, namely a velocity that can be attributed to some particular point on the graph of this data. The average velocity shown here in the formula is really nothing but the rise over the run between two successive points on the graph. Let's take a closer look at what we mean by average velocity. Let's look at two successive points on that graph. One of them is a measurement that was taken at time t0. Another one is a measurement that was taken a little bit later at time t0 plus h. Now, what do we mean by average velocity? Basically, we mean the slope of the line connecting those 2 points. So pretend that this is a straight line. Let's magnify it. So the coordinate of this point will be t0 and the value of y at t0. The coordinate of this point will be t0 plus h and the corresponding value of y at t0 plus h. Well, the slope is simply the ratio of the rise over the run in that graph. The rise is going to be a difference of the two y coordinates. That's going to be y at t0 plus h minus y at t0. The run is going to be the difference of the two x coordinates, and that's clearly h. And this is precisely what we mean when we say average velocity. So the average velocity is a kind of slope. It's a slope between 2 points on the graph. What about the instantaneous velocity? The instantaneous velocity will be related to this by taking measurements that are closer and closer together. So as it were, h will become smaller and smaller. As h becomes smaller and smaller, our average velocity will approach what we call the instantaneous velocity, which is what we will refer to as the velocity at the given time t0. The instantaneous velocity is what we get when we take that same average velocity, that's what this expression is right here, but we shrink the time interval between measurements. So the idea is we compute an average velocity and then we take a limit as the time increment h gets smaller and smaller. We'll see how to do that in concrete examples in this and later chapters.